Hello everyone, this is ML Naruto. Welcome to my channel. So, just a minute. Okay, so today I'll be discussing the topic that is performance analysis of an algorithm. So, for example, you have uh, some kind of algorithms like this. This is the algorithm one, and this is the algorithm two. This is the algorithm three. So, out of these three algorithms, you need to pick that particular algorithm, which is the best optimum algorithm, right? So, how do you evaluate the performance of the algorithm? Each algorithm has its own performance, right? So, you need to evaluate that particular performance, and based on that particular performance, you need to pick that best algorithm out of these three. So, how to do that? We have some kind of indicators. Those are nothing but the uh, input input data size, okay, or size of the input data, whatever you call. So this is indicated by small n, right? And the second one is the time, and the third one is the space here. So I'll be explaining each of these three indicators, using which we can easily analyze our performance of any kind of algorithm, right? So first of all, I'll be explaining the time here. So how to measure the time? So time is usually measured by the key operations, right? So we have some kind of key operations in our algorithm. So those are nothing but, we can also call it as comparison operators. Comparison operators, or you can also call it as comparison operations. Okay, so whatever. So this particular time is usually measured by these key operations that are actually performed by the algorithm. For example, this is my algorithm, right? So here I'll be giving some kind of input data. Okay, so here I'll be giving some kind of input data, and in the return I'll be having some kind of output data. So in between this particular, within this algorithm, there are some kind of operations maybe running actually. So those operations may be maybe greater than, or less than, or equal to, and not equal to, and greater than or equal to, or less than or equal to, whatever maybe. And or these are all the comparison operators, right? So these operators usually compare one thing with the other thing. So based on these comparisons, we will be having our output data here, right? So here what I'm saying is, for this, if our algorithm needs to compare the things within this algorithm, that our algorithm will usually use the comparison operators. So if we want to use this comparison operators, it will usually take certain amount of significant time. So it will take significant amount of time here. Why it is actually taking this significant amount of time? Why? Because it needs the algorithm will usually take certain significant amount of time to run the algorithm itself, right? So if the algorithm needs to be executed by comparing all the things here within the algorithm, so it will make use of some kind of comparison operators. So for that, our algorithm will take some kind of time to run that particular algorithm. So for that, so based on these comparison operators, we can easily calculate our time complexity, right? So this is the first thing here. And now the other thing would be the space. That is the space complexity. So what is the space here? In any kind of a problem, we'll have some kind of variables, right? For example, we have a is equal to maybe ml Naruto, right? So this is a string, right? And b is equal to maybe 29. So this is a number or integer. And c is equal to 59.76. This is a float. So likewise, we have so many kind of data types, and for that, each of the data types we can easily store them in any kind of a variables here. These are the variables, right? A, B, C. These three are the variables, and these are all the constants here. 29, 59.76, all the things. These are the constants here, right? So other than these other than these variables, we also have certain kind of instructions. So these instructions will be telling our programming language to execute our code, right? So these are some kind of instruction steps here, right? So what I'm trying to say is all these variables, and all these instruction sets, right? Using these variables and instruction sets, we can easily calculate the space. Why? Because if we want to store some kind of data, that is, let's imagine this particular example, that is ML Naruto. This is a kind of a string. I need to store this particular string in my variable, that is A, right? So how can I do that? I need to have some kind of memory space, right? So this is my memory space. So I need to allocate some kind of memory space if I want to store this particular string in a variable, that is A. And in the same way, I also need to have another memory space if I want to store this particular integer, that is 29, in the variable, that is B, right? So for likewise, for each, if I want to store each of these data types in a particular variables, I need to have some kind of memory space, right? You can also call it a space or memory space, whatever. So likewise, you also need some kind of memory space if you want to store this particular instruction steps, right? So what I'm trying to say is ultimately you need some kind of memory space if you want to store all these variables and the instruction steps to run a algorithm, right? So for that, you need some kind of memory space. So based on these variables, based on this, based on the memory that are actually occupied by these variables and that are also occupied by these uh, instruction steps, based on this particular memory space, you will usually calculate your space complexity, right? So that's it. So this is the base, this is the simple overview of the time complexity and the space complexity. Now I'll be explaining in a greater detail what is meant by time complexity, right? With the help of a real world example. So the first thing I'll be explaining is the time complexity here. So the time complexity. So what is the time complexity usually? In layman terms, you can also call it as it is the amount of time taken by an algorithm to execute on a computer, right? For example, this is my computer screen. This is my desktop. Let's imagine this. Maybe this is my desktop, right? So in this desktop, I'll be writing some kind of code here, right? I'll be writing some kind of code in any programming language, maybe Python. You can call it as a Python. So here I'm writing some kind of programming language, some kind of code here, that is printer, maybe ML Naruto. Okay, so I'm trying to say just print some kind of string here. So likewise, maybe some basic operation, that is 2 plus 3 equal to how much. So likewise, I'm trying to say my Python I'm just giving some kind of tasks to my Python so that I'll get some kind of desired output, right? So time complexity is that amount of time to perform all these operations or all the code on my computer to get my desired output, right? So this is the amount of time. This is the amount of time to get to execute all these commands to get a desired output. So that is nothing but the time complexity, right? So running time required by an algorithm depends on the input size. For example, any problem will have some kind of input data, right? So any problem will have some kind of input data, and that problem will usually provide some kind of output data, right? So in between these two, we have some kind of algorithm. here input data will be passed and you will get our output data, right? So depends upon this particular, the time complexity will usually depends upon this particular input data. Let's imagine I have passed some kind of data set, right? Which is having maybe 2 rows and 6 columns. Sorry, maybe maybe some maybe some 12 rows and 6 columns. Okay, I have passed some kind of data set which is having 12 rows and 6 columns to my algorithm, and I have got some kind of output. Okay, can you imagine what is the time taken by our algorithm to run this particular code? Can you imagine? Maybe let's assume the time taken to run this particular code uh, on our computer system is, let's imagine that is some maybe 10 seconds. Let's assume, okay, this is just a rough estimation. Maybe our computer has taken some kind of 10 seconds, our python has taken some kind of 10 seconds to run this particular code on our computer, right, which is 10 seconds. Okay, so what if we also have another kind of data set which is having 1 billion rows. Okay, our data set is actually having, this is another data set. So this is the first data set, right? This is the first data set, and this is the second data set, which is having 1 billion rows and 2 million columns. I'm just taking this as an example. Okay, so this is another data set which is having these many rows and these many columns. This is the second data set. Can you imagine how much time does this algorithm required to generate my output? Can you imagine the time here? Earlier the time was 10 seconds approximately. Okay, but now can you imagine? I'm sure what I mean, I can definitely say that this particular time will definitely be greater than the earlier time, right? Earlier time taken. So how can I say that? Why? Because in the earlier scenario, we only have 12 rows and 6 columns. So this indicates this is actually a simple data set. It's actually a simple data set. Okay. But when you look into this particular second scenario, your data set is actually having 1 billion rows and 2 million columns. This is actually so huge. So you can definitely say this is not a simple data set. This is a complex data set. It's a complex data set, right? So it's a complex data set. So I can definitely say the time taken by my algorithm to run this particular code, some kind of code, or to import my data set is definitely be greater than the earlier time taken by the algorithm, right? So I can definitely say this scenario. So these are the two separate scenarios. In this scenario, the time will be definitely lesser, and in this scenario, the time will definitely be higher. That means the algorithm will take some huge time to compute the operations here. Why? Because the data set is actually huge. So what I'm trying to say is ultimately the time complexity will usually depends upon the size of the input data. See here, I'm saying time complexity depends upon size of the input data. That is, you can call that size of the input data as n, small n, right? So when you ask me what is the size of the input data, size of the input data is nothing but the number of items in the input data, right? So just look at here. Here we have some 12 rows and 6 columns, right? So here in this first data set, so those are nothing but the items in the first data set. But when you look at here, we have 1 billion rows and 2 million columns. So these are nothing but the items. These are the number of items in this second data set, right? So this is nothing but the size here, size of the input data. This is also the size of the input data here. So depending upon the size of the input data, our time complexity will usually depends upon, right? So if I say time complexity will usually depends upon the size of the input data, then what does that mean actually? What does that mean actually? So I mean to say is, if my size of the input data, that is n, if my n is actually increasing, if my n is actually increasing, then what happens? Ultimately, my runtime, right? So you can also call it as time or runtime, whatever. Runtime will always be increasing, right? For example, if my input size of my input data is very simple or very small, then I can definitely say my runtime will always be definitely decreasing. Why? Because my data here is very much small here, right? So that's it. So now here, while running the algorithm, key operations such as comparison operators will take some kind of significant amount of runtime compared to the assignment or any other operations. For example, what is this statement is indicating here? So we'll have something called key operations. We something have will definitely something have uh, called as key operations. So what is meant by these key operations? These can also be known as comparison operators. Comparison operations, right? So these are nothing but greater than, less than, equal to, and not equal to, maybe, and or not. These are all the comparison operators, right? These are all the comparison operators actually. So these are all the usually these are all the comparison or the logical operators, right? So these operators will usually take significant amount of time. That is, these may take huge amount of time than any other operations. That's what I'm trying to say is, for example, if I say I want to check if uh, sorry, okay, I'll explain you with the help of some kind of code here. So see here, I'm assigning some value, that is n is equal to maybe 10. Okay, then what happens? Okay, so see here, what I have done is, see, I'll explain. See here, first of all, I have assigned some kind of value to my n here, right? So here I have assigned n is equal to 10, and also I'm saying uh, if I'm passing, I'm just running some kind of, I'm writing some kind of if statement here. That is, I want to check if my n is equal to 0, or is it equal to 5. I just want to know whether my n value is equal to 0 or is it equal to 5. If any condition is satisfied out of these two conditions, see here, out of these two conditions, if any condition will get satisfied, then I want my Python to print some kind of statement that is, hey, welcome, right? what if my n value is not 0 or it is not equal to 5? Then what happens if my n value is something other, some other else, I mean some other thing? So then in that case, I am saying else. That means if my n is not 0, if my n is not 0 and if my n is not 5 also, then what I want to do, I need to loop into the n here. So for example, what is the value of the n here which I have given earlier? That is 10 here, right? So I'm saying if my n is not equal to 0 or if my n is not equal to 5, then just go into the loop here for n number of times and print my statement that is by for n number of times. So what happens if I run this particular code here? I will be getting this particular statement that is by for n number of times. So what is the value of n here? That is 10, right? So I'll be getting this particular statement that is by for 10 times, right? So I'll show you how to do that. So I'm just hitting shift enter. See here, I have got some kind of values that is by 3, 4, 5, 6, 7, 8, 9, 10. Right. So I have got the statement that is by for 10 number of times, 10 times, right? So how I am getting like these many times? For example, if I manipulate this particular value, maybe I'll say maybe 20 here. So what if I hit shift enter? Now also I have got so many kind of values which are nothing but the 20 times I have got this particular by statement as for 20 times. Why? Because my n is 20 here, right? So what I'm saying is the time complexity will usually depends upon the input size. What, see here, I have passed n equal to 20, right? So when I hit shift enter, it has taken me some kind of milliseconds, right? But what if I give 200 here? If I hit shift enter, see here, it is actually taking some kind of time, right? So this time is nothing but the time complexity. Why? Because 200 is not a small number. It is actually a very, very big number, right? So for that reason, it is actually taking so much amount of time. So what I'm trying to say is depending upon this particular input value, input data, our time complexity will usually depends upon, right? So here, what I can do is for the sake of simplicity, I'm assuming the n value as maybe 8 here. Okay, see here. So I have got the by value for 8 times. What if I have given my n value as 0, right? So I have passed my n is equal to 0. Then what happens if it enters into this particular condition? If n is equal to 0, it will usually print the hey welcome. It will only print the hey welcome this statement for one single time, right? See here, if I hit shift enter, see, I have got this hey welcome statement for only one single time. Why? Because here I'm not passing something looping here, right? So the loop will usually starts from this particular line. That is the fifth line here. See here, from the fifth line, it will usually starts the looping here. But now here my condition has been satisfied. That is, I have passed n is equal to 0, and here the condition is if n is equal to 0, print the statement that is hey welcome, right? So here you can say that if the condition is satisfied, I'm getting this particular statement that is hey welcome, right? So here what I can do is I'll just try to teach you something like see maybe n is equal to 0, right? So this n is equal to 0 is nothing but, see, this n is equal to 0 is nothing but the C1, right? So cost 1, you can also call it as this is the C1, right? And this is the C2. The second line is nothing but the C2. And the third line is nothing but the C3 here. And the fourth line, that is else, nothing but the C4. Sorry. Actually, this is the input data, right? So it won't be considered as the C1 actually. So this is the C1. This will be considered as the C1 here. So if n is equal to 1, so this statement is considered as the C1 here. And now this print function is considered as the C2. This else is considered as the C3. For loop is considered as the 4. Print statement is considered as the C5. So likewise, we'll be having some 5 costs here. So I'll be explaining what are all these things. I'll be explaining. Okay. So here I have told you that time complexity is usually depends upon the size of the input data. Right. So time required for an algorithm depends on the time required for each statement also. That means, for example, so yeah, this is the true actually. For example, n is equal to 0. That means our algorithm will usually take very less amount of time to run this particular uh, algorithm, right? Why? Because our input data is very less. N is equal to 0. What if our input data is very huge? Then it will automatically take some huge amount of time to compute, right? So this is one thing, and we also have another thing, right? That is nothing but the each statement here. Each statement, for example, maybe the second one is maybe the second one is here. I'll be writing something. Okay. So yeah, I'll be explaining this. For example, I have a statement that is if. Here I have said n is equal to maybe 10. Here, but I also have said like I have said if my n is equal to 0 or n is equal to 3. Now what I want to do is print hey, welcome, right? Now if this condition is not true, that is if the condition is something else, like if the n value is something else, then I'm saying just execute this else statement. What I'm trying to print in the else statement here? I'm saying my Python to enter into the loop, that is for I in the range of n here. Like what I'm trying to say is I'm saying my Python to loop for n number of times. That's why I'm passing the range of n here. Now I want to print some statement for n number of times. What is the statement here? ML Naruto. This is my statement. I want to print this particular statement for n number of times here, right? So this is the usual scenario. So what I'm trying to say is usually the time complexity will usually depends upon the two things here. The first thing is size of the input data, right? Size of the input data. So the first thing is our time complexity will usually depends upon size of input data, that is n is equal the value of the n value, right? The value of the n here. So it usually depends upon this particular value of the n, and it will also be depends upon uh, how much each line is actually taking to getting executed, right? For example, if my Python is actually comparing some kind of n value with the value of n, right? It is actually comparing if the value is 0 or if the value is 3 or not, it is actually getting checked. So this statement is nothing but the cost 1, that is C1. And it will also executing, if this condition is true, it will also executing the some kind of statement. So it is cost 2. So it is the cost 3. It is the cost 4. It is the cost 5. So we'll have some 5 kind of costs here. So our formula would be, the time complexity formula would be like this. So the time complexity formula would be T of small n, right? So this is the time complexity of the input data will be equal to C1 plus C2 plus C3 plus what happens? C4 into small n, right? Into small n plus C5 into small n. So this is the formula here. So what is the meaning of this formula actually? So what is mean by the C1 here? First look at this particular value, that is the C1. C1 is nothing but this particular line. My Python is actually checking if my n value is actually matching with these values or not. If n is 0 or if n is 3 or not, it is actually checking. So if my Python wants to check for the n value, whether it is 0 or 3, it will usually take some kind of time. That time is nothing but the C1, right? And after checking, if my n value, let's imagine if my n value is 0, just imagine my n value is 0, then what happens? It will usually checks the condition. Okay, it is the condition is actually matching here. Now it will automatically immediately prints out the statement, that is the second statement, this statement, print hey welcome, right? So my Python will usually take some kind of time to print this particular second statement, that is hey welcome. So that time is nothing but the C2 here, right? So let's imagine my n value is not 0. Okay, my n value is something that is 10 here, right? So what happens? My Python will usually checks for the n value, whether it is matching with the 0 or 3 or not. It will usually check. For example, my n value is 10 here. That is, it is not equal to 0 and it will also not equal to 3 here. That means we will skip this condition and you will definitely skip this particular statement here. Now, my Python will enter into this particular third statement, that is else condition here. So what is the else condition here? It will usually confirms that my value is not 0 and not 3. That means my value is something that is n equal to 10 here. So for confirming that thing, my Python will usually take some kind of time. That time is nothing but the C3, right? After that, in the else block, it will usually goes into the for loop, right? So it is, my Python is actually saying that I will enter into the loop here for n number of times. Why? Because I have passed a range is equal to, I mean range of n. N means for how many times does this particular n value has. For that many times, my Python will print something called some statement called ml naruto, right? So if my Python wants to enter into a for loop, it will usually take some kind of time, that is C4, right? And after entering into the loop, my Python wants to print some statement, some string, that is ml naruto for n number of times. That is, for example, if I have 10 as my n value, then ml naruto will be printed for 10 times, right? What if my n is some 100? Then ml naruto will definitely be printing for 100 times, right? So for that, my Python will usually take some kind of time, that is C5, right? So these are all the times here. That is, C1 is the time taken by the first statement, C2 is the time taken by the second statement, C3 is the time taken by the third, C4 is the time taken by the fourth statement. But here, wait here. Let's come back here into this fourth line here. That is C4. See, C4 is nothing but the time taken by fourth statement into n here. Why I am passing n here? Why? Because here it will usually loop for n number of times. In the earlier statements, we don't have any kind of loop here. That's a direct statement. It's just checking whether n is equal to 0 or 3. If it is meeting the condition, then it will usually prints out the statement. But here that's not the case here. It after checking the condition, after confirming that n is not 0 and 3, it will usually enters into the loop for n number of times here. So that's why I am multiplicating my C4, that is the time taken by the fourth statement, into n number of times, right? And after that, C5 is nothing but the time taken by the fifth statement, that is print here. And what I'm trying to say, my print statement is actually inside this particular for loop, right? So my print statement is actually inside this particular for loop. That means whatever I want to print, that is whether it is ML Naruto or whether any kind of string, hi or bye or anything, right? So that will be printed for these many times, that is the n number of times. So automatically I need to multiply again my time taken by the fifth statement into n here. Why? Because these statement, that is ML Naruto, will be printing for n number of times. So that's why this would be my formula here. T of n, time complexity of input data, is equal to C1 plus C2 plus C3 plus C4 into n plus C5 into n. This formula is only relevant for this particular problem, right? So if the problem is different, then the formula would also be having some kind of different structure here. So this formula is only applicable for this particular problem, right? So that's what I'm saying. What if, just imagine, if my n is equal to 0. Okay, here just imagine, here instead of having the n value as a 10 here, I have taken n is equal to 0. Then what happens? It is actually meeting the condition, n is equal to 0. Then what happens? It will usually prints out the statement, that is hey welcome. Then what would be my formula here? T of n is equal to C1, right, plus C2. That's it. This is my formula here, C1 plus C2. There would be, there will not be, there won't be any kind of C3 and C4 and C5. Why? Because by now, by this particular statement, my program has been successfully executed. There is no need to enter into this else block and enter into the for loop again and enter into the print statement here. Why? Because the condition has been already satisfied. I have already met the condition here. That is, I have checked the condition, that is n is equal to, n is actually equaling with the 0 value. Then then I have just printed hey welcome, right? So that's what it has happened. So the formula would be, now T of n is equal to C1 plus C2, right? It will usually depends upon the input size of the input data, that is n. If the value of n is something, then the formula would also be different, right? So that's the thing here. So now, just look at here. So if n is equal to 0, so these are all the things, right? So here in this thing, we will be having some kind of worst scenario and the best scenario. First of all, we will be discussing the worst case scenario. And now here I'll be discussing the best scenario. Okay, so what is the worst scenario here? Okay, the worst scenario would be, what is the worst scenario means the maximum amount of time taken by the algorithm to run all these steps. Okay, what is the maximum amount of time taken by our algorithm to run all these steps? So what would be the maximum amount of time? Maximum amount of time would be the n value here. Maximum amount of time means if n is not equal to 0 and n is not equal to 5, then that value would be the maximum amount of time, right? For example, what I'm trying to say is, see here, here I'm said, here I have already said n is equal to 0 or n is equal to 5, right? So if this condition is true, I'm saying my Python to print some kind of string that is, hey, welcome. Okay. So this is the best scenario. This would be my easiest way. The time taken to execute this kind of thing is very, very, very low. It will take very, very less amount of time. But what if the condition has not been satisfied, and now it will usually enters into this particular else block? Then it would be very, very difficult for our algorithm to execute. That is, the time taken will usually be very, very high. The time will usually be very, very high. Why? Because it is the first condition has not met, so it will usually loops for a number of times. Then automatically the time will gets increased. So that's why the worst case is nothing but the maximum amount of time taken by the algorithm to run all the steps here, right? So here in this worst case scenario, my n value, worst case would be if my n is not equal to 0, and sorry, or if my n is not equal to 3, then this is my worst case scenario, right? This is my worst case scenario. Then what happens? Our formula would be T of n would be, what happens? Maybe C1 plus C2 plus maybe C3 plus C4 into n plus C5 into n. So this would be my formula in the in the worst case scenario, right? So worst case scenario means it will usually computes all the costs here. That is cost for the first line, second line, third line, fourth line, and the fifth line. It will usually computes all the costs here. So if my Python will usually computes all the costs here, then automatically the time taken by the algorithm to execute itself will usually be higher. So this is the worst case scenario. And what is the best case scenario here? The best case scenario would be if my n value has met the condition. That is, if my n value has equal to 0 or it has met with the condition 3, then automatically it prints out the first condition, that is the hey, welcome. So this would be my best scenario. Now, what is the formula? What would be the formula of the time complexity here? P of n is equal to the first, it will usually takes the C1, right? So this would be the C1, C2, and the C3, C4, C5, right? So now this would, what is the formula for this T of n for this particular best case scenario? What would be the formula? It will, the condition has been met, right? So the condition has been met. So C1, I will take C1. And then what this particular string will get printed, that is C2. And that's it. My algorithm will stop here at this particular point. Why? Because the condition has been already met. That is, the condition has been already satisfied for either 0 or for either 5. So T of n will usually become C1 plus C2. That's it. It won't enter into the C3, C4, C5. So this is the best case scenario. This is the worst case scenario. This is the best case scenario, right? Okay. So now I'm clearing all the things here. Okay. So now, uh, okay. So now I want you to have look at something, right? Okay, so here what I have done is, here I have just defined some kind of function. I have created some kind of my own function, that is linear search. Here I have passed two parameters, that is the input list one parameter and the element is the another parameter. So I'm saying my Python to loop into this items, that is index and the value in the enumerate function. Inside this enumerate function, I have passed a input list here. So I'm saying finally, if my value is actually equal to the element here, so I need to I want to return some kind of index here. I need to know the index, right? So here I have said return -1 here. So what does it actually indicates here? You'll get some better amount of clarity after after when I try to compute the problem here. So just be patient. See here, what I have done is, uh, first of all, I have created some kind of function, that is linear search. Okay, so if you want to understand this particular function, you will definitely needs to understand this particular problem here. See here, I have created a list manually, that is with the variable name input underscore list, right? So in this particular variable, I have passed some kind of list, that is 3 comma 4 comma 1 comma 6 comma 14, right? And I also have created another kind of variable, that is element, with the integer, that is 6, number 6, right? So now I want to know, if I want to know the index of this particular number, that is the 6 here. See here, where is the 6 here in this particular list? 6 is here, right? So I want to know what is the index number of this particular value. Usually what is the index here? Just try to look at this particular thing here. See, this 3 is having the index value 0, 4 is having index value 1, 2 is having index value 2, 6 is having index value 3, 14 is having index value 4, right? So if I try to execute the code, I need, I mean, the answer should be this thing, that is the 3 here. I need to know the answer, that is 3, right? So when I try to enter this code, when I try to execute this code, particular code, that is, I'm saying print, what is the print here? The print statement here, index position of the element here, right? Sorry. Okay. So here what I have used is f string here, f string. So using the f string, I'm saying index position of this particular element. What is this element here? Element is 6. So I need to know what is the index position of the 6 here. Okay. So I have passed the function which I have earlier defined, that is the linear search function. This function I have passed here. So inside this function, I have passed the two parameters. One is input list, that is this particular thing, and another is element, that is the number which I need to know my index, that is the 6 here. So if I have passed the linear search function, and inside that I have passed input list, that is this thing, and element, that is this thing, right? That element is this thing. So I have passed these things. What happened is, I have got the index position, that is the 6 here. That is nothing but 0. 0 index position is 3, 1 index position is 4, uh, 2 index position is 1, 6 index position is 3 here. So finally I have got the index position for the element 6, that is 3 here, right? So this is the thing. So but you don't need to worry about this particular definition function here, defining the function. Why? Because in the later parts I'll usually explain how to define any kind of function in the later series, right? So this is the data structures and algorithms. So you need to focus on the main concept here. So this is pretty much simple. I have defined some kind of function that is linear underscore search. Inside this, I have placed some two kind of parameters or the arguments you can call input list or the element here, right? So I'm saying for any kind of index comma value in the enumerate function, that is the input list, if my value is equal to element, right? If my value is equal to element, then I need to return the index value, and this return would be -1 here, right? So obviously it will gives you the right index for your value. That is this thing. You just need to focus on this particular problem. Later in the later parts, I'll definitely explain what is meant by this, right? So earlier for this problem, I have already calculated the best scenario and the worst scenario, right? So for this problem also, I need to calculate the best scenario and the worst scenarios. So how to do that? See here. Maybe I'll explain this particular part here. So here my problem is having input list, okay, is equal to, I have some kind of list 3, 4, 1, 6 and 14, right? This is my list here. And what I have said is I have also assigned some kind of variable, some kind of integer to my variable, that is element, that is maybe 6 here, okay. So now I want to print something that is index position of element. Index position of my element is, what is that? I need to use linear search, okay. So I'm using the linear search function here. Inside this function I'm passing input list parameter, and also besides that I'm passing element parameter. So it will automatically gives me the output as output will be 3 here, that is 0. See here, the index positions would be 0, 1, 2, 3 and 4, right? So obviously the index position for the 6 digit is 3. So that's what I have got the answer as my input, right? So I'll explain the best case scenario and the worst case scenario for both of these things, okay. So the best case, see here, okay. First of all, I'll explain you the worst case scenario. What is the worst case scenario in this particular problem? Worst case is nothing but the maximum upper bound or the maximum amount of time taken by our algorithm to run itself. So what would be the maximum amount of time that is taken by our algorithm? So if I say the element is equal to 6, then what happens? It will usually checks for the element 6 starting from the index number. That is, it will check for 6 here at this particular position, and then this, and then this, and finally it stops here, right? So likewise, what would be the worst case scenario here? The worst case scenario would be if my element value, if my element value is equal to 14, or uh, or if it is not in the list, or if element is not in the list here. So what I'll explain both the cases here. The first case would be if the element is 14. What happens if the element is 14? What happens is, for example, if the element is 14 here, right? Let's imagine my element has been 14. So it will usually checks for the first index number, that is 3, which is wrong. It is not actually matching with that. So it will then goes with the index number 1, that is the 4 here. No, it is actually not matching. It will moves on to the another place, then it will checks for the 14 value. No, it is not matching. It will checks for the another value. It is not matching. So the worst case scenario would be here, that is the 14 value. Here it is actually matching here at the last position. Okay, so up till this particular position, my Python will usually checks for the 14 value, and it will usually compares this particular 14 value with each and every index of my input list, right? So this would be the maximum amount of time taken by the algorithm to execute the code here. That is element, if my element is equal to 14, right? So now I'll explain another kind of scenario, which is, that is, if my element is not present in my list, what happens? For example, if my element is maybe 20, right? If my element is 20, so how to do that? It will usually checks this particular value with the present value here. For example, okay, so see here, it will usually checks for 20th value in my see here, this is my list, right? 3, 4, 1, 6 and 14. So it will usually checks for 20th value. So it will first goes on to this first position. It will checks for the 20th value, which is wrong, not matching. It will goes to the second. It goes to the second position and checks for the 20th value, which is not matching. Goes to the third position, checks for the 20th value, which is not matching. Fourth position, not matching. Fifth position, it is also not matching. So by this scenario also, it is usually checking for all the places here, right? So this would be the worst case scenario for any kind of algorithm. If the value is out of the input list, or if the value is the last among the input list, then this would be the worst case scenario, right? So this would be the worst case scenario for any algorithm to execute. Why? Because why this is the worst case means, beyond this particular 14, there are no numbers. So that's why our algorithm will usually check for all the values. It will usually checks for all the values, which is an absolute time waste, right? So this would be the worst case scenario here. And in this scenario also, if my element is not actually in the list, then also my algorithm will usually checks for all the values, which would be a great time waste for my algorithm. So these two scenarios are usually considered as the worst case scenarios. Now I'll explain the best case scenario for this particular problem. Okay, so what would be the best case scenario here? See, my input list, 3, 4, 1, 16, right? Just imagine this is my list. And now what would be the best case scenario? The element here. What would be the value of the element, so that this situation will turn up as the best situation here? So I'm talking about the best case scenario, that is the best possible scenario. That means the lowest amount of time, or the minimum time. Minimum amount of time taken by the algorithm to run itself. So what would be the minimum amount of time taken by my algorithm to run, to execute the entire code here? it would be possible only if the element is equal to 3 here. Why? Because see here, just imagine the list here, all the elements in the list. The first element here in this particular list is 3. So if my element is matching with the first element of the list, then it will automatically executes the print statement, that is uh, the index of element, the index of element 3 uh, is maybe 0, sorry, linear search of input list comma element here. So this would be my print statement, right? So did you get that? So this is the print statement here. See, what I'm trying to say is, if my element is 3, then what happens is it won't it would my Python will usually stop at this particular position. Why? Because the 3 is actually matching with this particular 3, right? So my Python won't check for the rest of the elements. So we will be saving some kind of good amount of time, right? So by this we are actually saving some good amount of time. So that's why the best possible scenario would be if I provide the element as 3, that is actually matching with the first element of the input list here. So obviously it will usually run in the best possible time. That is, it will it will give me the output as index position of 3 is 0, right? So that's the thing here. And now I have another thing. And now I have another thing, that is the average case runtime here. So what would be the average case runtime here? So the definition would be it is the average runtime. It is the average runtime for all the possible input values. So I'll explain with the help of an formula, that is T of n is equal to 1 plus 2 plus 3 plus 4 plus and so on plus n, right? So these many statements we will definitely have in any kind of code. So n number of statements will usually have, and for that each of the statements we will have n number of costs here, that is c1 c2 and so on cn, right? So we also have the input size of the input data, that is n here. So you can also be represent this entire formula as like this: n of n plus 1 divided by 2n. This would be the simplest formula for calculating the average case runtime. Why? Because we are actually averaging it, right? This divided by 2n is indication of the average here. This term is the indication of the average. Average means dividing by 2. Okay. So in most of the real world applications, we will only be using the worst case analysis only. We will not be touching this particular average case runtime or the best possible runtime. We won't be looking for this particular analysis. We will only be looking for the analysis which is the worst case scenario. We will only be looking for the scenarios that is the worst case scenarios. Why? Because any company or any kind of management will usually wants to know what would be the maximum amount of time taken to run this particular code, so that they can plan the things really well, right? So what is the meaning of this is, see here, for example, I have said if n is equal to 2, print hey. Okay. elif n is equal to 5, print hola, else print don't know. Let's imagine this is the scenario here. So my n value would be, for example, I'm giving the chance to my user to enter some kind of input. That is, I have told my user to enter some kind of input. So the user has already entered some kind of input. For example, he has entered n is equal to 100, right? So my Python will usually checks for first condition, that is n equal to 2. Whether is this matching? No, it's not matching. So it will usually goes on to the second block of code, that is elif. So it will usually checks for the n equal to 5, whether it is matching. No, it is not matching. So it will usually goes to the third block of code, that is else here. It will now won't check. Why? Because if the two previous conditions are actually false, then automatically my Python will print out this print function don't know. So what I'm trying to say is, in this worst case scenario, uh, the n value would be not equal to 2 and not equal to 5. If n value is not equaling to 2 and it is not actually equaling with the 5, then this would be considered as the maximum time of algorithm to execute the code here, right? So in most of the real world scenarios, this worst case scenarios will only be considered. Why? Because companies really want to know what would be the maximum amount of time taken by the algorithm to run itself, right? This is the thing. Now I'll be explaining the best case scenario also. I mean, you guys already know that best case scenario, best case runtime you can call, right? So what would be the best case runtime here? Just simply take this example here. Take this example. What would be the best case runtime here? See, I'll explain you. So the best case would be, I have already told you, right? Maybe, okay. I'll explain you here also. So here in this case, the best case scenario would be, if my n value is equal to 2, then it would be considered as the best case scenario. Why? Because my Python will usually goes into the first line and it will usually checks for this value, whether it is matching or not. It will checks. If the value is actually matching with the 2, then it will usually prints this function and it will stops at this particular block. It won't be entering here, right? It won't be entering into these third and fourth steps here. It will just stops here. So it would be the best lowest amount of time, that is, it would be the minimum time of my algorithm to execute the piece of code. So this would be considered as the best case runtime, right? So this is the best case runtime and this is the worst case scenario here, if n is not equal to 2 and n is not equal to 5, right? So yeah, I think I have explained enough for this video. So these are all the great concepts. I think by these by now you have got some real good amount of understanding uh, how to analyze or how to evaluate any kind of performance of any algorithm, right? So this input, data size, and the time and the space, all these things I have already explained really well. I mean, I'm assuming this, you need to tell whether I have explained this very well or not. You need to think, or you need to say, if my concept is very much clear, then please share this video with your friends or with your family who are in need, so that you can help them. And if you like the content, just hit like as usual. Okay, so yeah, that's all for this video. I'll see you in the next video with the continuation of it. So in the next video I'll be explaining the space complexity in a greater detail. So in this video, I have told you regarding the time complexity, right? So in the next video, I'll be explaining the space complexity in a greater detail, right? So just don't forget to subscribe here. Okay. Yeah. Yeah. That's all for this. I'll see you in the next video. Bye bye. Take care. Jai Hind.